Now that we have the idea of joint probabilities, we understand that concept, we understand the concept of independence, mutually exclusive, let's talk about a couple of general rules. The first one is the general addition rule for probabilities. Now, given two events labeled A and B, the probability that A occurs or B occurs is given as the probability of A or B. This is an or. This little thing right there means or. That's the union, if you remember from algebra, A or B, is equal to the probability of A plus the probability of B minus the probability of A and B. Now, the justification for this will make a little bit more sense, I think, in a Venn diagram. So here's A. Let's just say here's the event B. If I look at the probability of A, that would be all of this. If I look at the probability of B, that would be all of this. And you see here I've overlapped this area. So I've actually counted this area twice, which is the joint probability of A and B. So because I counted it twice, I have to subtract it off once. That's the justification for this piece right here. Now, this is an OR statement. There is such a thing known as an exclusive OR. The way we're using OR here, it means that A could happen, or B could happen, or they could both happen. Because if they both happen, then it's true that A or B happen. An exclusive OR says that A happens or B happens, but they both cannot happen. In the situation we have an exclusive OR, you'd have the probability of A or B equals the probability of A plus the probability of B minus twice the probability of A and B. Because I counted this middle twice, I have to subtract it off twice. Now, there's not typically a symbol for exclusive OR. There would be terminology that says exclusively A or B. And actually, this is rare in this level of a class. I probably would not give it in my class, though it could be like an extra credit question or something like that. But typically the idea of an exclusive OR is not in an introductory level of class. But I want you to be aware that it exists. Now, in the special case where we know that A and B to be mutually exclusive, we still have the same situation here. However, it's become so much easier. Because if I go back to a Venn diagram, here's A, here's B, because I know they're mutually exclusive, they share nothing. So this piece will be 0. So in the special case of the mutually exclusive, the probability of A or B is simply the probability of A added to the probability of B, because there is no joint. They don't share anything. So that's 0. So if I know ahead of time A and B are mutually exclusive, then finding the OR, the addition, is really quite simple. Now, this is the prior academic year, the sample data that we used earlier. So find the probability of freshman or option A. So this is the probability, and I should do this as empirical, of freshman or A. This is going to be equal to the probability of a freshman plus the probability of option A minus the probability of freshman and option A. So probability of freshman, here's the freshman total. There's 15 out of 60. Plus the probability of option A, that's 20 out of 60. And then I need to subtract off the probability of freshman and option A. Well, here's option A. Here's freshman. Right there's the and, that's 5 out of 60. And what I end up with is 15 plus 20 minus 5. That's 30 out of 60, or a half. Now, earlier I said in my class, if you're one of my students, then if you report a probability greater than 1 or negative, you lose more points than possible. This is exactly where that sort of thing can happen. Here, where we're safe, if I messed up and I skipped this piece, I would have had the wrong answer, but I would have ended up with 35 over 60. So that would have been no big deal. But suppose that this happened to be a 25, or actually I need a little bit bigger than that, say a 45. If this was 45, 45 and 20, that's 65 out of 60. So you end up with a probability bigger than 1. That's because I didn't subtract off the needed piece. So even though mathematically it's impossible to get a probability greater than 1, you could make an algebraic error. You could apply this rule incorrectly and end up with an answer that is bigger than 1. Or likewise, if you miscalculated this or put these in the wrong order, you could end up with something negative because of an algebraic issue. Now let's find the probability of a junior or a senior. Well, that's going to be the probability, I should put this on here, of a junior or a senior, which equals the probability of a junior plus the probability of a senior minus, sorry, I kind of ran out of room here, probability of a junior and a senior. Well, let's go back up to the table. Okay, here's my juniors. Here's my seniors. You can see there's no and here. Juniors and seniors are mutually exclusive. So I have 21 out of 60 and 9 out of 60. So this is going to be equal to 21 out of 60 plus 9 out of 60 minus 0. Because this piece is 0. They don't share anything. So this is going to end up being 30 out of 60.